Question number 12. Urn A has 5 white and 7 black balls. Urn B has 3 white and 12 black balls. We flip a fair coin. If the outcome is heads, then a ball from a urn A is selected, whereas if the outcome is tails, then a ball from urn B is selected. Okay, so what's the probability of selecting a white ball? So first, let's define our events. Let's say H is the event that the coin is heads. Represents the event that the coin shows heads. So its complement will be the coin shows tails, obviously. So let's write which color we selected from urns. So let's say white represents, W represents the event that a white ball is selected at the end. And of course the complement will be a black ball is selected at the end. Okay, so it's asked that what's the probability of selecting a white ball? Actually, before calculating this one, let's write the given probabilities. So we already know probability of heads will be 1/2. Also, it will be equal to probability of head complement as well. It's same as the probability of coin shows tails. Okay, this is simple. Let's write probability of white if we know the coin shows heads. If we already know the coin show heads, let's check it again. If the outcome is heads, then a ball from urn A is selected. So we need to look at the urn A. In overall, we have 12 balls, and we need to find the probability of getting a white. So in the denominator, we will have 12, and in here we will have 5. The probability of getting white ball, if we know that the coin shows heads, is 5/12. So let's write the other ones. Probability of white complement, which is black, given that the coin is heads, we can easily write it like this: 1 minus probability of white known that heads equal to 7 divided by 12. We can just move it here and calculate the probability. And then we need to find the other ones as well. Probability of white, given that the coin is tails, which is head complement. Let's check the information again. it says if the outcome is tails, then a ball from urn B is selected. And in the urn B, we have 3 white and 12 black balls. So in the overall, we have 15 balls and 3 whites in the urn B. And then calculate the probability of getting a black ball if the coin shows tails, which will be 1 minus probability of whites, known that head complement, which will be, let's erase this part, 12 divided by 15. Okay, so in the section A, it says what's the probability of selecting a white ball. Let's calculate. Actually, let's delete this A. Let's calculate probability of white. Let's open it up first. Probability of heads multiplied by probability of whites given that heads plus probability of head complement multiplied by probability of whites known that head complements. We have to find this to calculate probability of getting a white ball. So let's write the probabilities. Probability of getting heads is 1 over 2. Probability of white given that H is 5 divided by 12 plus probability of head complement, which is probability of tails, again 1 divided by 2 multiplied by probability of whites given that head complement, which is tails, was 3 divided by 15. And the answer will be 37 divided by 120. Okay, let's solve section B. In the end, if we observe that a white ball is selected, what's the probability that the coin flip has resulted with heads? Okay, so if we observe that the white ball is selected, what is the probability that the coin flip has resulted with heads? Okay, so it asks us to calculate probability of heads if the selected ball was white. Let's open it up. Probability of head intersection with white divided by probability of white equals probability of heads multiplied by probability of white known that heads, probability of heads multiplied by probability of whites given that head, plus probability of head complement multiplied by probability of white known that heads complement. So let's write the probabilities. So probability of heads is 1 divided by 2. This is 5 divided by 12. Again 1 divided by 2 multiplied by 5 divided by 12 plus 1 divided by 2 multiplied by 1 divided by 5. And the answer will be 25 divided by 37. Okay, let's solve section C. In section C, it says if the coin is not fair and the probability of having a heads is 0.3, what's the probability of selecting a white ball? Okay, the dice is not fair this time. The coin is not fair this time. Sorry. So let's rewrite our probabilities. Probability of heads is 0.3 and probability of head complement is 0.7 this time. Okay, so again we need to calculate the probability of getting a white ball. Let's open it up again. Probability of heads multiplied by probability of white known that heads plus probability of head complement multiplied by probability of whites known that head complement. Yes, we need to calculate this one. Let's write the probabilities. This time probability of getting heads is 0.3 multiplied by other probabilities are not changed because we didn't change the number of balls in the urns. So we can use the previous probabilities to solve this problem. So this was 5 divided by 12 plus probability of head complement is 0.7 this time. Actually, let's write it like this. 0.7 multiplied by the probability of white known that head complement is 3 divided by 15, which is 1 divided by 5, and the answer will be 53 divided by 200. Let's solve the section D. In section D it says assume C and answer B. So we need to assume the coin is not fair this time and solve the question section B again. Okay, so in section B, D, we need to calculate this probability of heads, if you know the ball is white. We need to open it up again. Probability of heads intersection white divided by probability of white equals probability of heads multiplied by probability of white given heads. Probability of heads multiplied by probability of white known that heads plus probability of head complement multiplied by probability of white known that head complement. Let's put the probabilities. Only thing we need to change is the probability of heads and head complements, because the only thing changed is the dice. The dice is not fair this time, so that's why we need to write 0.3 for the probability of heads, and the other ones is not going to change, multiplied by 5 divided by 12, and 0.3 multiplied by 5 divided by 12 plus 0.7 multiplied by 1 divided by 5, and the answer will be 25/53.